So today I'm going to talk about data mesh, and it might be a new topic to some of you. It might be something you've already seen, but I'll try to see if we can answer as many questions as possible towards the end. So before that, I just want to get a sense of how many of you are developers here? Okay, how many of you are data engineers here? Data scientists, analysts? Okay, a few hands here and there. Okay, and how many of you are passionate about data? Need not be someone who is doing it today, but quite a few hands, right? Okay, so today we are going to talk about data mesh, and hopefully we'll get a sense of what it is, how is this concept different from what exists today, and feel free to ask me any questions, and you can ask in Thai, and the MCs can translate for you. All right. So what is data mesh, right? I know a few hands went off for data engineers. You might be familiar with data platforms. I know before my talk, P and Manisha talked about data platforms, right? What we see is still with data platforms, the companies haven't been able to become data-driven. So that's the reason data mesh came into play a couple of years back in Thoughtworks by Zhamak Dehghani, who used to work before in Thoughtworks. And this is like what microservices does to monolith, data mesh does to data architecture, right? How many of you have built microservices? At least one so far. Okay, few hands here and there. So you can think of how microservices to monolith, you have data mesh to data architecture. And we'll talk about that a little bit more in detail. So it brings in domain-driven design to data architecture. It helps you see data as a product. We'll see what it is. And it also makes sure that people who know the data are the ones who are giving it off for analytical use cases. So there are a lot of new things here, and hopefully we'll talk through this in this session, right? So when to consider data mesh? I know a few people raised your hands for data scientists here, right? Are you working in like machine learning, fraud detection, cancer cure? Any hands? Some solid machine learning stuff. I think Kun Virod was talking about machine learning. And when do you consider data mesh? You consider data mesh when you have complex analytical use cases. So how this fraud detection happened today? Like you have so many scam calls coming in. How does it get detected? Because you need to get a lot of data to actually write a model that will detect a fraud or a scam, right? The second is if you are in a big company, you have a lot of people who are giving you data, who are getting data from you. That's what we call as the producers and the consumers, right? When you have a large number of producers and consumers, data mesh is applicable to all of them, right? And we are looking at enterprise when there are so many teams which needs to share data with each other. You are working on rule engines, you are looking at machine learning stuff, you are looking at reporting stuff. So in all these use cases, we can apply data mesh, right? And when you have a big team, a large number of teams, you have equally large number of use cases that overlap with each other, right? And these are all places where data mesh can play a role to bring in more value from the data. I think in the last two talks, we were talking about data as oil, data as gold, but are we able to tap into the value yet? No. So we'll try to see how we can do that in this session, right? So why is it important? I think I saw a few hands on data engineers. I'm a data engineer myself. I've been part of a big data platform team in my company, previous company. And what we used to do is take data from a number of systems, give it off to data analysts. So we had these people who, connect to a database. Then you're actually taking in data, you're transforming it, and giving it off for data scientists. What is wrong with it? There's nothing wrong with it, actually. And we saw that you can build data platforms the right way in the previous session. But where are we going wrong? We are seeing that only 24% of the companies have become data-driven. Why is that such a small number? Everyone's investing in data. But why is it still low? One is data quality issues that I think the previous talks were mentioning about. The other one is data is seen just like I'll just create an Excel sheet, let me just throw it to you. You do whatever you want, right? But there is no people and process around data. And the third, the data platform team that P and Manisha talked about, they're already always overstressed because every source in the company, it's the data platform team that needs to connect and get data from. So this is what happens, right? So you have operational data plane, which is all your source systems. So you might be dealing with databases, you might be dealing with, how many of you don't connect to a database today? You haven't touched a DB at all so far. Anyone? Okay, hopefully then all of you have touched at least one database in your life, yeah? So you know what the operational data plane is. It's your source systems where your data comes in. Right? What is this data pipeline layer? That's the data platform team. So they are like the people who are the plumbers who are sitting in, taking in data from one place, doing something with it, giving it off to the analytical data plane, which is your data scientists, analysts, your BI engineers. All of them are sitting there to crunch this data, take it forward, do some insights out of it, make something useful out of it, so on, right? Now the problem is this ETL layer that you see here is actually the people who don't really understand the data. They know how to take data from place A, give it to place B. That's all. As a data engineer, I know how to probably write a Spark code, deploy it on AWS, take it to, give it off for data scientists. But if you are giving me data, Sowmya, you need to do cancer cure research. You are a data engineer, bring me the right data. I don't know, because I don't understand the domain, right? So who understands this data the best is the producers of the data, the people who are responsible for the operational data plane. That could be your finance teams who understand finance data the best. It could be your medical teams who understand medicine data the best, right? But what happens today? Everything sits with the data platform team to get it from place A to place B. So what happens? One, you are not able to scale because the data platform team doesn't have the knowledge of what this data is about. They might not be able to derive the best value out of data, right? Second is, if I'm always in a constant thing of, I'll try to help the consumers, I don't know the data, then I don't have time to spend on making my system robust. So the things that the previous talk talked about, observability, security, would I have time to do all these? No, because I'm constantly helping my users understand the data which I don't understand, right? How can I understand someone who wants to do cancer cure when I don't understand the data, right? The third is everyone is moving from legacy. Everyone is moving to the cloud, which is the right thing, but it puts a lot of pressure on the data platform teams. That's the reason why just 24% of companies have become data-driven. I know each and every one of us will be working in an enterprise that wants to become data-driven, and probably this session will help a little bit in moving in that direction, right? So what is the objective of data mesh? It says that the people who are giving you the data for operational needs, what is an operational need? You have day-to-day reporting going on. You want to actually give it off, onboarding a new user in your microservice. You have a database for users. So the folks who are actually taking care of operational needs are the ones who can take care of data from analytical needs. So what we are saying is, if there is a team that's taking care of your day-to-day transactional databases, they understand the data the best, let them take care of giving it off for analytical needs as well, right? So I'm going to just quickly pause here to see if there's one question, because it's important to understand why are we doing data mesh before we say, how do we do data mesh? Any questions so far? I'm going to assume everyone's understood if there's no question. Is that right? Okay, let's move on. Maybe I'll have a quiz towards the end so that I'll check if you got the concept. Okay. So how does it work? So there are 4 principles of data mesh. And all the 4 principles need to come together to say, this is a data mesh-based architecture. And we'll see what it is. One is domain ownership. The second is treat data as a product. The third is self-serve data platform, which the previous talk touched upon. And the fourth is, it's quite a long word, and I'll dissect it for you. It's a federated computational governance, right? And we'll talk through all of these in a bit more detail, right? Domain ownership. Maybe I just want to quickly pause. Anyone can give me an example of a domain? from your use cases? What is a domain? If you could just shout it out. What domains have you built microservices in? Anyone? Payment. Awesome. Payment is a domain. Anything else? Customer is a domain. Fantastic. Customer is a domain. Team. Sorry? Okay. That's a domain. Cool. Okay. So what is a domain? 20 years back, Eric Evans is the one who started domain-driven design. And why did it start? Because we were just building systems without a connection to business objective. What domain-driven design brought about is say that, hey, let's draw a boundary along business objectives. So you have payments as a domain, you have customer as a domain, and you have many such domains that you mentioned, right? Each of them have a business objective, right? So in your company, you have finance as a domain, human resources domain, marketing domain. And each of them have a business objective. So marketing domain will have like how many campaigns have been successful so far, right? And what we are saying is we have been treating our applications in a domain-driven way, but we haven't been treating data in a domain-driven way. Why is that? Data is part and parcel of every team, right? So that's what this asks us to do. Let's look at data within domains. Let's take data as every domain is responsible for giving data out for analytical use cases, right? That's the first principle of data mesh. Let's look at data the same way as how we look at applications today. We have microservices. We are doing a great job. Let's look at the same thing for data, right? And once you start decomposing within a domain, what we say is that the data also needs to have use cases for a given business objective, right? So for marketing data, I'll probably have analytical use case. Can you predict the number of campaigns I'll be able to run next year based on today's data, right? That's an example, right? Now I've created a domain. Now we are saying you should take care of analytical data use cases. What do we need to do next? We have been talking about data quality, data governance. There should be someone, a team that's looking at data and governing it within the domain, and those are the data owners. And the data owners are best placed within the domain where business and tech comes together to say that I know about this domain, which is marketing domain. I know what the data generated in this domain is about. And I know what quality checks need to go through this to say that this is a trustworthy data. And that is the role of a data owner, right? The second role that you see here is a data steward. Data steward is someone who is there on a day-to-day basis to make sure that any access to the data or day-to-day operations, if there are any errors, taking care of that so that anyone who is consuming data from the domain is getting trustworthy data. So it's a combination of data owners and stewards who take this responsibility, right? Now the third one is data product owners. We'll talk about that more. What we are doing is data product owners have the responsibility of finding out how can I make the best value of data, right? For example, you have blocks of gold sitting in your house. What would you do? You have blocks of gold sitting in your house. No value until you turn it to a jewelry. No value if you're going to sell it, right? But why are we doing this with data? Everyone is building a data lake, but they say, I have so much data, I don't know what to make out of it, right? If you're treating it as a goal, then you should have a product owner who knows how to give the best value out of this data. And that's the third role, which is the data product owner role. Yeah? And then there are developers who are there in each domain to make sure that you are building the right APIs, building the right pipelines, so that you can give the data for analytical use cases, right? So once this is done, what we are saying is each of these domains are not going to give just data for operational use cases. They also give data for the one marked as D, analytical use cases, which is for machine learning purpose or BI reports. This domain is responsible for that, right? Let's just take an example of, I think many of you might be listening to podcasts here. Any of you using Spotify, any other podcasts? Quite a large group, right? Yeah. So what are some of the domains that you see in a typical company like Spotify? You have artists as a domain. So artist domain needs to be responsible for having the entire list of artists, onboarding a new artist, paying a new artist, right? The second is podcast itself. What podcasts are getting registered every day, right? That's a domain. The third is who are my users. I should have a users database. I should know which parts of the country they are from. Then there's a media where your audio, video, you have other things, right? Now, if you look at artists as a domain, you see the thing that's marked as O is operational API, where I am paying an artist, I am onboarding an artist, which is my day-to-day thing, which is an onboarding, like it's an operational thing. But what we are also saying is historical artist data that is used for getting insights from the data is an analytical thing, which is marked as D here. So the domain's responsibility becomes not just operational APIs, it also becomes the analytical APIs, right? And if you see these domains don't exist in silo, you have an arrow going from media to artists, which is saying that each domain needs to speak with other domains to collaborate, aggregate this data, and use it for something better. So artists might be looking at, I want to know the daily stream by artists, what media have they actually run through so that I can engage my customers accordingly. So it's used by another domain, right? So what we have seen so far, treat data the same as how you're treating applications today. You are having microservices that are domain-oriented. Let's also have domains taking care of data for analytical needs within those domains with the right roles, right? Good so far? Okay. Data as a product. What is a product? Is this mic a product, do you think? Yes? How about a water bottle? Is it a product? I think we need some more exercises to do for the crowd. Cool. So is water bottle a product? A product is something that gives value to the users. Anything that gives value to you. A water bottle is giving some value to you. This mic is giving me some value, right? So what we are saying is let's treat data as a product, something that gives value to a set of users. And how do we do that? Right. So let's take the example of a water bottle. Now I'm looking for, I want to drink some water. And you should probably have some water bottles towards the end of the hall, or there is a vending machine and stuff, right? But when discoverability becomes hard, I don't know where to get water from, right? So I was just looking during lunch where the water is, but it should be there somewhere. Similarly, data should be made discoverable in the sense that you should have a place where you say, these are the data sets that are there in my enterprise. Maybe it's a catalog. Catalog is where I register these data sets and make it discoverable for users to come and see, hey, this is a data set I have. Hey, I'm a customer domain data owner. These are the data sets I have that you can use, right? Make them discoverable, right? This is not just the responsibility of people. If you're even a developer, you will be generating some or the other data every day. Are you making it visible to other teams? Are you making them useful for some other team is the first thing of a data as a product, right? Second thing, I know that there's a vending machine with water bottle, right? Now, I need to key in some bar to actually take that water bottle out, right? I need to address it some way. I need to have a way to access that. So that's the second aspect of data as a product, is where I am making this an accessible, addressable one, right? The third is trustworthy, right? I think many of you would have gone for trips, and when you go far, far away, would you just open up the tap and drink water? If there are folks, you're really brave. I give it to you that. Would you just open up the tap, you find it brown, still drink water? Then you're even more brave, right? So similarly, when a data is given to you, you have Excel sheets, create some reports, create an ML model that works off it. Now, the quality of the insight is as good as the quality of the data. If I want to trust the water, I want to know it's labeled, it's actually said what is the processing that has happened, it's oxygenated water. I have a label and I trust that water bottle because I know what processing has been done on it. Similarly on data, this is what it's called as lineage. I should know where the data has come from. What processing has happened on this data so far so that I can trust that data, right? That's the first aspect of trustworthiness. The second is data quality. Can I actually run, is it ISO standard on the water bottle? Then I know, okay, it has gone through some control checks and so on, right? So similarly, it has to go through relevant data quality checks, your structural checks. Is it the right structure? Is it having all the domain-specific data quality checks that have been run on it? Then this data becomes trustworthy, right? The third is self-describing, in the sense data should have enough metadata to say, what is this about? Right? You have an Excel sheet. There should be enough information about the data that each column in this data set is corresponding to something, so that I know, I discovered, I take the data, I know how to use it, right? Fifth one is you want to link data. Like how many of us will have two files. In one file, customer name is last name. In one file, customer name is first name. How would you link then? How would you link? You'll probably give some random offer to some random customer, right? So in order to be interoperable, you should have agreed on what each column in the data set actually means in the enterprise. If you say customer name, it should probably be a combination of first name and last name in this sequence, right? So agree on a standard way of defining data elements. The last one is secure. I think we saw about security. There should be enough network controls, authentication, role-based access, and anonymization to say this is a secure data product, right? So when we say a data product, it's a combination of the code that creates the data, the metadata along with the data, and the infrastructure where you host it. For example, I'm giving in AWS S3, I'm giving a CSV file, the code that I'm using for generating the CSV file, the infrastructure, the Terraform code that I have for setting up AWS S3, everything combines as a data product, all right? So let's go back to our previous example. In this case, artists, podcasts, and users. In case of data product, the artist data product gives out the history of artists that we saw in the previous slide. And if you're looking at podcasts, it could be that tell me which podcasts are being listened to in which demography, which regions of Thailand are listening to which podcast. So these things become a product of its own that I can give out via SFTP, REST-based API, streaming, any ways of giving it to the users, right? So far, so good. Any questions so far? If you don't ask, maybe I'll ask. So, any questions so far? Is that clear? So we have created domains. Each domain is going to create data products of some value to the users. Now we are coming to the third thing, which is self-serve data platform. How many of you have used Kubernetes in your day-to-day stuff? 1, 2, 3. Quite a lot, quite a lot. Maybe one of you can say, why are you using Kubernetes? It's not a product question. I'm just asking, why are you using Kubernetes? Any of you who raised the hands here? Maybe this side, if anyone's raised. Easy to use? Yeah. Does it give you a lot of aspects that you don't need to start from scratch, like scalability, deployability? Perfect, thank you. So when you are running Docker images, containers, what Kubernetes gives you, it's a platform that abstracts out a lot of things you don't need to start from scratch, which is it could be easy to deploy. It can take care of when the pod goes down. It will bring it up. So it can take care of your cross-functional concerns. So when we say each domain is going to build their own data products, we are also saying that not every domain needs to start things from scratch. We are saying that there would still be a centralized platform, which is self-serve in nature, which is going to give out capabilities that the domains can use to create data products easily. So let's say Kubernetes, you're able to run a Docker container so easily on that. So you need not ask every domain team to write something from scratch. Similarly, say if I want to create a CSV file and give it off, write a Spark code that can transform the CSV file, add a few columns, push it into S3 bucket, which is a blob storage. The domains need not write this from scratch. They can rely on the self-serve data infrastructure platform, which will give these out as capabilities. So one thing this will do is you don't need to start from scratch. So the domain teams can start using these capabilities really well. The second thing is, when they are not starting from scratch, we are also making sure that time to create data products comes down. So today, if you want to create a data, you want to give it off for analytical use cases, it's going to be taking months because you need to get data into a centralized platform. You need to create the analytical workspaces, Jupyter notebooks for those of the data scientists here. But in this case, it brings down the lead time to create data products by a whole lot, right? And what we are also saying is data engineers are hard to find in the market. And in which case, each domain need not have data engineers. A domain can have polyglot developers who can actually work only from a business objective standpoint. They need not worry about writing transformation code, right, on Spark or specialized one, right? So roughly, if you are to categorize what are the capabilities that a self-serve data platform can provide, you can bucket them into 3 categories. One is from a data infrastructure point of view. It could be that setting up a networking or setting up storage that you want, setting up network security controls with role-based access. All these things are abstracted out into the data infrastructure plane, which is a very low-level plane. And if I'm part of the self-serve data platform, I need not give this out to the domain teams. So they can simply be not touching the infrastructure side. The second is data product developer plane. If we want the domains to create data products, then it will give you all the APIs that can help control the lifecycle, building a product, versioning a product, securing a product. All these APIs are given out from a data product developer plane. So when I say plane, it's just a category of capabilities that the platform will give you in a self-serve way, right? The third is mesh supervision plane, and that is your cross-cutting ones. If I want to discover data, then you want all the domains to register their data sets in a central data catalog that people can come and discover from. Or you're looking at standard governance policies like PDPA, your regulations and compliance. All these things will form as part of the mesh supervision plane, right? So we saw domains having data products in them. And we saw the third one, which is the self-serve platform. What it does is it helps the domains create data products really easily, right? So we are here, and we are going to the last pillar, which is the federated computation governance, right? What is federation? In some countries, you have some policies that are at the country level, and some are at the state level. So I'm just giving an example of probably the states in the US or in India. You have probably defense. The country defense sits at the country level, which is a central policy, right? But if you're looking at police, it's at the state level. What is this? This is a federation of responsibilities, where we are saying that not everything sits at the center, but you are distributing the responsibilities between the state and the center, and that's federated, right? So what are we saying here? This whole umbrella that you see is at the enterprise level, you have certain policies that are global in nature. Your PDPA concerns, your regulatory concerns, all these things are at the enterprise level, right? But at the domain level, you will probably have something additional. So if you're working in a hospital and they ask you to say you have to expose all your data for sharing, right? Now, if I'm an admin in hospital who is taking care of payroll and stuff, okay, payroll is a domain. But if I'm someone who's taking care of clinical records, I'm in a domain that's much more sensitive than a payroll domain, right? So what we are saying is, when we are giving out policies from a federation standpoint, we have certain policies that should be at the company level, which is all your PDPA regulation ones. At the team level, at the business domain level, you will have certain responsibilities that you give the teams to take care of. And we'll see what are some of the examples, right? And wherever possible, we are going to implement these governance policies on the data platform. Like we talked about lineage, we talked about quality of data, we talked about discovery of data. This is all part of data governance, because governance is I am able to secure my data, but still be able to let my users access good quality data, and that is governance, right? And wherever possible, what we are saying is we will automate these policies on the self-serve platform, so that whenever there's a domain who wants to create a product, you have standard governance policies that are applied for each of them, right? Okay, I'm not sure how visible this is, but if you're looking at responsibilities at the enterprise level, you'll have, can I actually look at what a data product should look like, right? What kind of metadata elements should I take care of? Creating a customer name is a combination of first name, last name, sits with the enterprise. The third one is, how can I identify the boundary of the domains? Some people ask, this is a question in any DDD, right? How big a domain could be. You could actually have a domain that says insurance. But in an insurance company, you can't have just insurance as a domain, right? You'll have claims, you have payments, you should, that responsibility of what a domain could look like is an enterprise level concern, right? But at the domain level, you will have, how can I create a schema for the data sets? How can I give out the APIs for giving out metadata? What kind of incentives can I give to my teams to create good data products? This is all a domain level responsibility, right? That's the federation that we are talking about. And when we say computational, we are making sure that it's actually implemented on the self-serve platform. So if you're looking at lineage tooling, if you're looking at schema creation, upgrade, all these are implemented on the self-serve platform. It's not something you manually check every time someone wants to do governance checks. You don't ask them to go through 10 people to do that. You have it on the self-serve platform, right? So we are towards the end. I wanted to touch upon privacy-first data mesh, which is, by nature, data mesh tries to implement privacy really well. How it is? Because one, you have already classified domains into different levels of sensitivity, right? The clinical records and the payroll that we mentioned is already divided into domains of sensitivity. The second, when you give people responsibility, they actually understand and try to do the best to make it privacy first. So if I'm giving responsibility to the clinical records team, they know how to give data products that make sense for others, but still keeping privacy intact. For example, you want to do the same cancer cure use case. If I have so many personal data in my data set, you can't say it's a fully sensitive data, you can't do anything about it. So what happens in cancer cure today? They actually see, how can I anonymize? Maybe in an email address, I remove everything before the @ I give the domain name, right? Similarly, if it is an age, I won't say age is 21, but I would say the age is between 20 to 25, right? So what we are doing here is, when we see records, we are not able to pinpoint and say, hey, Sowmya is this X-year-old lady in this area, and if they come after me with a record, that's going to be bad, right? So that is a violation of PDPA. So that's what we are saying, that domain data owners, people who are closest to the data, understand how to anonymize the data enough so that you can still keep it private and you are able to give it off for some use, creating some utility out of it. And each domain becomes a trustable boundary, because you're giving someone responsibility, they'll make sure that they are giving you trustworthy data, right? And what federated governance also empowers is the domains to build privacy-first design. When you give responsibility, they'll do a good job, right? And the self-serve platform helps you implement these enterprise-wide governance policies. And we are also saying you can do a lot of things in the privacy-preserving tech space. I don't know how many of you have done differential privacy or heard of this, differential privacy, homomorphic encryption, federated learning. Any of you here who have, that's a space that, something that's really going to grow, and where it says that you can still maintain the privacy of data. Even after encryption, you can do some processing on the data. That's the basis of privacy-enhancing technologies. And you could actually implement them into the self-serve platform, right? So, okay, I think we are nearing quiz time now. I'm going to summarize it all and open it up for questions, and if not, the other way around, right? Okay. The first thing that we saw, domain ownership. The way you see, look at microservices and applications, look at the same thing for data for analytical needs. Make sure that the domains are the ones taking care of data from an analytical standpoint. You have the right roles, such as data owners, stewards, who are making sure that this is good quality data that's being given out. That's the first principle that we saw. The second is don't treat data as something that you throw from one team to another. One Excel sheet just flies without any meaning. Don't do that. Treat data as a product, because when you say data is gold, data is oil, data needs to be treated as a product. It has to become discoverable. It has to become accessible. It has to be really trustworthy and secure for it to say that this data is a product, right? The third is how can we make things easy? Let's do a self-serve, centralized self-serve data platform that will take care of capabilities that the domain teams can use to create data products, right? So that's the third one. And the fourth one is federated governance, where it's a responsibility between domains and the company itself, where you are having a division of responsibilities. You are implementing these policies on the self-serve platform wherever possible and making it computational in nature, right?